Well, I found somebody online who talks about how to set up the microphone, so they claim with these new settings there won't be a hum. I've tried it a few times, but anyway. So, after yesterday, I decided I was sitting there going, I don't know what to talk about, even though beforehand I knew a lot to talk about. So today I created notes, and I don't need notes. I can just wing it. So, okay, where are those notes at? Yeah, so what have I been doing? Here we go. Halite. Halite.io. There's a programming contest called Halite.io. It's a machine learning contest. And that's about it. No, it's you can enter it in. There's like 20 different possible programming languages you can enter it in. And this year is turtles. The idea being that you're supposed to write a program that controls individual turtles, and you can have as many as you can create. You gather resources with the turtles, and then once they have enough, they can create more turtles. It's okay. Last year's was spaceships flying around. Then you had to zoom around planets and stuff, and that was kind of cool. But this year's just it's more tedious in some way. I haven't quite figured out how. Last year I ended up in the top 1% ish, and this year I'm in the top 5% ish. So I don't know. It's just a different kind of problem. I don't know. Maybe I'm debating whether or not I want to put in the effort to try to get to the top, but I have these other things that I'm working on too, such as these online classes. There's a bunch of ones. I was looking at the Coursera one. A friend of mine was taking a couple. He mentioned about programming languages, functional programming languages, and sounded kind of interesting. But one on dynamic programming. I was like, that sounds cool. Because then you deal with large problems and how to come up with optimal ways of solving it, which is something I love to do. It's and they have data and programs, and they say, hey, here's some techniques. It's like, okay, I've heard the techniques before, and I've written stuff around it. And I came up with my own so far on the first lecture to get the performance I wanted for the certain ones. But the idea with their programming problems, they're large enough that you can't actually compute all possible combinations. So how do you solve a problem where it would take longer than the time of the universe to be able to have the computer to solve it? I mean, computers can never be fast enough to solve it, so you have to come up with new and interesting algorithms or different ways of looking at the data in order to say, these things can't possibly happen, just like a puzzle piece, right? I mean, if you have a giant jigsaw puzzle, you can look at a piece that has an angle like this and one that has an angle like this, you're like, that's not going to fit. So you don't even have to bother. So if you sort all those out and find only the ones with the matching angles, then you can say, you line them. Which is why you sort the edges first, right? You create a smaller pool of stuff to look for. If you had a 1,000-piece puzzle and you've picked up every piece and compared it to every other piece, you have to do 1,000 comparisons the first time. But then you'd eventually find two that match, but then you'd have to try, it'd be 999, then 998 for the next one, and then it just would take forever. Each one would be slightly close to 1,000 compares. But if you only have the edges, around the edges, there's like 1/10 that number of pieces. And so you only have to have a pool of 1/10 the number that you have to compare. So maybe 100 or so. And out of those 100, it's easier. Then it's only 99 to compare. And it's the same thing with all the dynamic programming. There's tricks to say, is there a way to sort these? Is there a way to pull out things that are different from others or things that can't possibly fit? Or if you have a backpack and you can only put so many things in, once you're trying to pack a couch into it, couches then can fit in a backpack. I mean, unless you're Doctor Who. Even then. I don't think he has a backpack then, but or Mary Poppins. There you go. Mary Poppins had a bag of holding. You can put anything in you want. So that's an interesting class. I'll probably finish off with some of those things. And the reason I wanted to do that in the first place is that I've noticed in all the places I've coded. I've been a programmer for over 30 years now. It's hard to believe. I know time flies when you're sitting in front of a computer all day long. But it's when you're trying to solve problems and you're working at a big company, usually you end up with the fastest machine available. Like when I was at Apple, they had the prototypes for new machines and you ran stuff on that. And it's great for changing your development speed. So you can develop code a lot faster and you don't have to wait an hour for something to run. And it'll take 5 minutes to run because it's that much faster, 12 times faster. But the problem is, though, you have your algorithms, which could be orders of magnitude slower. Like I was saying, sorting the puzzle piece versus another one. And so for me, I always like a language that works fast so I can try new ideas out quickly, but is actually kind of slow to run. So that's why I usually use Python for things. I mean, most of my career I programmed in assembly language, and people are like, then why do you use Python? That's like an entirely different kind of language. So assembly language, you're working at the machine level, you're you're flipping bits, you're telling it exactly what to do. You can get billions of instructions per second, and Python is thousands of times slower. It's like, well, if I can get it to work in real time in Python, then it'll be really, really fast in assembly language. I mean, when I rewrite it to make it faster. Or if it may solve the problem right away. Maybe it's just a matter of working on a problem. You only need to solve it once. In that case, your time is more valuable. But if you're going to spread it out to billions of people, like if you're at Facebook and working on images like I did, then you want it to have it so that all the people in the world, there's a billion people out there. And if every person wastes an extra second of their life watching an image, that's a billion seconds you've wasted. I mean, that's a lot of people years. So the idea of saving every second you can on large scales matters. But if you're just trying to solve a problem once, like there's this programming contest called Project Euler that I used to enter in. And it was the same thing. It's you can program in any language you want, and you submit problems. And at the time, there was like 120 problems. I think there's 500 or 1,000 now. But that was like 10 years ago. And at some point, I had solved them all in Python because I could write it, and it would run in under a minute. That was good enough. I only ever had to run it once, so it didn't matter if it was the fastest. And it was fast. It solved all the problems. And it got me into the top 10 in the world at some point because I had solved all the problems. A new problem came out, and I was able to get the solution before most of the other people. I mean, only 9-ish other people were in the same pool as me. So the idea is speed mattered in that case. It was how fast can I get something done? And so I just, so the same thing for this Halite competition. I mean, they have faster languages like C++ or Rust. And there's other like functional programming. I don't know if there's an Erlang client. I know there's a Haskell client and some other ones. And I thought, oh, that'd be kind of cool. But for my first thing, I want to do it in Python just to show the algorithms, so I can test the algorithms. And I still have it running in, I think that the longest it takes is it's under 10 milliseconds per turn. And you're allowed up to 2 seconds. So out of 2 seconds, each turn can take 10 milliseconds only with the code I've written. And it puts me in the top 5% in the world. So just working on the algorithms, I think, is more useful. So any language that allows that, I think, is valuable. So, and also then I can make fun of all the C++ people because they have to spend all their time with memory management and all these other things. And my code runs as fast or faster than probably most of them. I've seen people take longer on their stuff, and anyway, it gives me a challenge and something to say. I have made it harder myself, and I still won. It's just fun. It's all fun, just like what do they call it? Razzing people. I remember. That's what they do. You razz each other, say, hey, guess what I did? So that's what I've been mostly doing. And also, that was all I'd written down. I only wrote down a few words, so just enough so I could comically look to the side every so often. But, yeah. So those are the programming challenges I have currently. I'll see how this video thing works. Like I said, the sound, that buzzing was kind of weird. So maybe I'll test out some video stuff and upload again another week or so. And then if I get everything, all the bugs worked out and kinks worked out, then I hope to keep recording stuff every day. Just keep track of the stuff I'm working on, the stuff I'm thinking, and I'll have different kinds of channels. So I have really vivid dreams every night, so maybe I'll have a channel where I just talk about the dreams I have. Or all the conspiracy theories I used to listen to and believe. And but for now, it was just I was thinking about these programming challenges, so that's all I've been focused on. It's I want to try different techniques. It's just work on myself and work on the algorithms I have and try to become better and better at it. That's what I like to do. So take care.